Hello again, a new day, a new experiment. And I have a AB-IOT-868. This is a patch. That's how a patch of that bidirectional amplifier is looking like. You see, I prefer to buy this kind of things instead of the whole thing, because anyway I have to put my own connectors, and there is a heatsink in the other version that I don't need it because I'm not using it for takes, continuous radio waves and blah blah blah. What I'm trying to do today is something very simple. So I will connect two pieces of wire here, plus and minus. Just want to see if we inverse the polarity, the amplifier is burning or not. You know, I'm gonna do this test for you, and I want to save you for some pain if we take it that way. Let me check how the patch is connected. You see, the patch is perfectly functional, you know, it's absolutely the same thing without the connectors, of course, and without that power plug. But we have the same things here. We got the trimmer for TX power, and here is the output and here is the input. This is a very clear way to do it. Anyway, I'm going to use a piece of PCB to have my own patch. Up here we have plus, the other one it's ground, and another ground and another ground, and here is the input and here is the output. Well, I'm not gonna do anything else for tonight but just the connection to the power supply, and that's it. If it's burning, it's burning, but at least I know what I have to do for the future. Should I insert a diode for protection, or it's no use? So plus goes up here, and this is the ground. Very nice. This is my power supply, and now it's set to 4.5 volts. Okay, let me check the polarity first. Plus to the middle, 4.5 volt. What do you think it's gonna happen? Let's insert the ammeter and we can measure the current. Okay, are we ready? And obviously it's working with 8.7 milliamps. This is a really nice amplifier, and you know, this current, it's absolutely marvelous. And now guys, shall we do it? Okay, here I have minus and here I have plus. Nothing, no 2.0, it's gone. 2.3 amps. Oh my, it's so gone. No, it's not. It's still working. That means we have a kind of protection. That should be interesting. Let's try once again. All right, maybe I should have a little protection. 180 ohms. Okay, let me see, maybe I have a better one. That should be okay. How much is this? Let's check it out. 1.9 ohms. Okay, so we have a kind of limitation, let's call it. Plus to the ground and the resistor, and there we go, 1.1 amps. Okay, this one is hot already. So I think there is a diode in reverse polarity at the input, and that prevents wrong polarity. But you know something, I don't want to bet on that. What I can say It's a really high current, so it's very possible in few seconds the diode will be destroyed, and then we'll start crying. Okay, let's open this guy and to check the board. Let's have the microscope up and running, and here we go. Let's follow this up there. This is very interesting. We have the plus here on this capacitor, and goes where? Right here on this capacitor. Then it goes where? This transistor here. Yes, and that's it. Okay, so the plus is going to this guy here, SATK, and nothing after. Nothing, 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 nothing. Okay, evidently here we have a power supply. This one with the coil, and we have a plus there, and a plus here. Okay, this is the power supply. I don't like the way this one is looking. A little bit away. It's a resistor with 0. Okay, maybe that's how they just plant it. SX5. What about this guy here? CO45. This one up here, it's C4TLY. Okay, and this is a SATK, but I don't see any diode here. Maybe this guy's up here? No. What else we got? A 5K transistor, probably. What we got here? SP6, 1GAF, and this is AZ2141 or something. RG, and this is the power transistor, SX5OH3892. No other stuffs. I don't see any diode around here. I think the single one who can do this kind of behave is this SATK. Okay, we'll try to find out what is that about, but in the meantime, let me have 2 connectors and let's check if it's still alive. Won't you? Let's see how can we connect this. Oh yes, very nice. Of course. Just like that. Now let's have the ground connected to 1 pin. And perfect. Okay, we are good here. Next one, the other side. That's the input. 1, 2, okay, and that's another ground here. Good to go. And another ground here. Maybe I'll try the other side. Okay, so we got the connectors in place. Now let's check the nano VNA. I'm not sure that's the input and that's the output. So I think the output goes here. And the input, yes, thank you. Go to sleep. The current to nano VNA on. And let's power the amplifier. Oh my god, I forgot about I need an attenuator because this guy have a lot of amplification and it's destroying my nano VNA. But now here comes another problem. I don't have the adapter for this, so I do some other stuff. Just tie it here. Obviously this guy, it's on, but I can see something strange there. The blue and green are getting together. Oh no. The blue one, it's pulsating. You see? That's because of the nano VNA. Let's see. Of course, yes. No, it's working. Okay. And look there. We have a clear amplification on minus 7.7 dB. And you know that one is because the nano VNA is sweeping the frequency, exciting the TX. But when I connect channel 0 to channel 1, there is a very clear amplification. Oh man, how can I do that? It's always like this, you know. Adapters and another adapters and para adapters. And makes me crazy. Okay, once again. Alright, I'm not touching that. You see, the nano VNA is clearly working. Okay. Power off. No more signal. Very clear. Power on. Minus 7.65 dB. And my attenuator, it's like 21 dB. So we have around 13 dB amplification. That's absolutely marvelous for this amplifier. And it's really nice and flat. Let me change this. Okay, stimulus. Start at 200 mega. Of course, it should be recalibrated and stop at 9010. You see down here, it's now it's sweeping all the band, and you can see the TX, it's coming up. Beautiful. $820, that's what I need. And people, yes, what can I say? Let's try that again. I'm inserting my amp meter. Okay, let's try some other way. I got the minus here. And obviously plus to a 1.5 ohms resistor. And there we go. Just for a short period. 1.3 amps. Oh, it's hot already. So now back again. Okay, I don't need it anymore. Minus to the ground and power on, and it's working. But I think this is very conclusive. What can I say? It have a kind of protection, but I don't bet on that. The current is way too big, so if you keep it like that for 5 seconds, then it's gone for sure. 1.3 amps through a resistor of 1.5 ohms, that's huge. And first time when I just connected it was 2 point something amps. I don't recommend to have this experiment. And finally, if you connect this and you don't have the LED instantly, just disconnect it, don't let it run. If I could be you, I will insert a diode in series to be sure that we have no problem with reverse polarity. And by the way, let me show you what I'm talking about. Here we have a diode. Yeah? And this is very simple to connect. Very, very simple. I really recommend you to do this. Here we go. You see, the diode here have a mark, a ring, a silver ring. And that goes like this. And that is plus. You see, the ring. And as arrow is showing, we apply plus here, and evidently plus is going to the amplifier. Okay, let's check this out. We have the plus connector here. Yeah, plus to the ground, and middle. There we go. You see the nano VNA working? Can you see that? Yes, of course. All right, now let's change polarity. And by the way, if we change the polarity, we have to connect the ammeter to see if it's any more current leaking. Now we come with the plus here. Okay, we have plus here and then minus to the ground. And look here, magic. No leaking, no current, nothing. Nothing. Let's have this like that. Wow, it's already going up. So a diode should be a way to protect the amplifier, and not only this, any amplifier. All right, I think it's useful because this kind of amplifiers are not cheap at all. So be sure that I will cry if I'm burning one of these, but in the same time, I did that in purpose. I didn't know what's happening, so I just risk it, to see what's happening, and I'm happy that now I have a very good result, and as you can see, it's working, it's amplifying. Oh, come on. And look there, very good amplification, very nice amplification, and hope it's useful. Happy Easter for all of you which celebrating this in the weekend, and see you soon with some other projects. Please like, please subscribe, and of course don't forget to have fun. Bye bye.